Hello and welcome to the Unit 1 Section 1 video on points, lines, and planes. So we're going to start off geometry here talking about some undefined terms. Okay, these are terms that we can't use other things to describe. These are your most basic shapes or most basic concepts in geometry. So the most basic figures in geometry are referred to as undefined terms. Okay, and the reason that they are called undefined, again, is because we can't describe them using anything else. So the most basic one is a point. A point names a location, and it has no size. So it has no thickness, it has no width, it has no length, and is represented by a dot. And we always use a capital letter to name a point. So ways you can name a point in notation. So here's a figure. This is our point. It's labeled A. So we can call this point A, like so. Or we can write the word point and say point A. Or, and this is probably the way you're most likely going to do it, you can just refer to it as its letter name. And remember, you must use a capital letter when doing this. Okay, so now let's move on to a line. A line is made up of infinite points. So whatever length of line you have, there is an infinite number of points along that line. Any 2 points can form a line, because you can take 2 points and draw a straight line through it, such as the one that you see here. A line has no width or thickness, okay? But it does have length. A line extends indefinitely in 2 directions. Okay? Left and right, up or down, north, east to southwest. Okay, 2 directions for each line. You name a line by any 2 points on a line or using a lowercase script letter. Okay, so here's a way that we can notate this line that's shown here in the figure. We can notate it by XY with our line segment on the top of it. We can notate it by YX, so you can write the letters in any order that you want, or we can notate it by simply saying line L. And that L is given here, and that's a script letter L. And we use the script letter L in any case because it helps us from getting it confused from the number 1 or the letter I. All right, and now the third thing that we want to talk about, let's go to another dimension up and talk about planes. A plane is a flat surface, and it is made up of points. Any 3 points make up a plane. A plane extends indefinitely in all directions. You can name a plane by any 3 non-collinear points on the plane or an uppercase script letter. Okay, so here we have plane P, as it's called, and it's got points A, B, and C, and they are non-collinear because they do not form a straight line. So we can notate it by saying plane ABC. We can say plane CAB. We can call it plane P using that uppercase script P. All right, now that we've gone over what points, lines, and planes are, let's talk about collinear and coplanar points. Okay, so collinear points are points that lie on the same line. Okay, so for example here, we've got line ABC, and this line contains all three of these points. So we can say that A, B, and C are collinear. Points that do not lie on the same plane are non-collinear, and you must use at least 3 points in describing it. Okay, so A, B, and C are non-collinear because they do not lie on the same line, and we cannot draw a straight line through A, B, and C. Okay, something that may help you with this is if you can draw a triangle between the 3 points. So if I can draw a triangle from A to B to C, and you end up with a triangle between the 3 points, then they are going to be non-collinear. Okay, so that's your little test. If you can connect the 3 points and end up with a triangle and not a straight line, then they are non-collinear. Non-coplanar and coplanar points. Let's start with coplanar. Coplanar points are points that lie on the same plane. Okay, just like collinear means the same line, coplanar means the same plane. So here, all 4 of these points lie on the same plane. So we can say that J, K, L, and M are coplanar. Over here, we have points that do not lie on the same plane for non-coplanar. You must use at least 4 points to describe non-coplanar. Okay, it's just like it took 3 to describe non-collinear, it takes 4 to describe non-coplanar. So here, J, L, and K are on the same plane, they're on plane P, but M sits outside of it. So therefore, if you were to talk about all 4 of the points, J, K, L, and M, then you can say that they are non-coplanar. It only takes 1 to not lie in the same plane for it to be non-coplanar. All right, intersections. 2 lines intersect at exactly 1 point. Okay, so here, point P is the intersection of lines R and S. 2 planes intersect along exactly 1 line. So planes M and L intersect at line K. Now that we've got a little bit of terminology, let's do some examples. Starting with example 1. Let's use the diagram to name the following. First, we want 4 collinear points. Well, line P has 3 of them, line Q has 3 of them, but line R is the only one that's got 4. And those 4 collinear points are H, N, K, and I. So H, N, K, and I. A line that contains point M. Well, point M is right here, so that would be line P. You can also call it by other names, okay? All you really need here is line P. That would suffice as your answer. But I want to show you alternatives because you do have options. We can call this line MN. We can call it line NO. We can call it line MO, just to name a few. You just pick any 2 points on this line. You can write those 2 points in any order you like, as long as they are both on the line, and you can name the line that way. All right, a line that contains points H and K. Well, here's H, here's K. They're both on line R. We can also call it HN, NK, KI, HI, any of those would work. So HK is one of many other ways that we can name it. All right, what's another name for line Q? Well, Q has the points J, K, and L on it. So we can just use two of those letters and name it any that we'd like. We can say JL, we can say JK, we can say KL. Those are just some ways that we can say it, but you only really need to give me one of those. And then the intersection of lines P and R. Okay, here's line P, here's line R. They intersect at a point, and they intersect at point N. If you just wrote the letter N here, that would be fine, because that's acceptable notation. All right, let's do example 2. We're going to use this diagram to name these following items. A line containing point F. Well, point F is right here, so that would be line J. I'll let you come up with other ways to name it. Another name for line K. So here's line K, so we can say, for example, BC, because both B and C are points on that line. A plane containing point A. Well, here's point A. It lies on plane M, so I'm just going to say plane M. By the way, while I'm thinking about it, you see how this line goes dashed here? This is to indicate that this is the part of the line that's below the plane here. So this part of the line is above the plane, this part of the line is below the plane, and then it comes out and it sticks out from below the plane here. Okay, so that's just to kind of help you visualize what's going on three-dimensionally here. All right, an example of 3 collinear points, or non-collinear points. All right, so we could say D, we could say A, and we can say E. Now, you're probably thinking, well, D and E are on the same line, but as long as one of them is not on the same line, then it works. So I'm going to say D, A, and E. You could have also said D, A, and B. You could have said D, F, and C. You could not say D, E, and F, and you could not say B, E, and C. Any combination of three points, any other combination of 3 points is fine. You just can't do D, E, F, or B, E, C, because those are examples of collinear points. And then finally, the intersection of plane M and line K. Plane M is here, line K is here, so we're going to follow this up, and it intersects at point E. For example 3, we are going to use this diagram to name the following here. 3 coplanar points. Okay, so let's see, we've got on plane R here, we've got V, W, and X. So I'm going to say those, V, W, and X. But I'm also going to give you one other example. Look at this pyramid that's sitting on plane R. Each of these faces is a plane, so we could say WZX as well. WZX for this plane that's facing this way. You could also say VWZ for the front face. This side back face, you could say VYZ. And then for this back face here, you could say ZYX. Okay? All of those are planes. And as long as the point's on the corner or on the edge, it's part of the plane. All right, a plane containing point X. All right, I'm just going to say plane R. Make it nice and simple. And remember, you got to use script for this case here, okay? The intersection of plane R and plane ZVY. So we've got ZVY here, okay? So it's this plane, and then plane R. Well, VY is the line that lies on that plane. So remember, planes intersect at a line, so the line is VY. You can also say YV. The number of planes that appear in the figure. Well, we've got plane R on the bottom, which does include this base of the pyramid. That's also part of plane R. Then you've got the 4 faces of the pyramid, so you have a total of 5. And the number of planes that contain point W. You've got plane R, because W is sitting on that. You have this front face here, and then this front side face here. So 3 planes contain point W. All right, for example 4, we're going to use the diagram to name these items. The intersections of lines L and M. All right, well, we've got line L here. So L is here, and M is here. So we've got point E as our intersection. Another name for plane Q. Well, let's see. We've got 4 points to choose from. We need 3 to name the plane, and they need to be non-collinear. So we can pick 2 off of the line M. So how about F and E? And then we've got I out here by itself. So we can call it plane EFI. Are points D and E collinear or coplanar? Well, D and E lie on the same line, but they certainly do not lie on the same plane. One's in plane P and one's in plane Q, so we can say they are collinear. They're both on line L. And then the number of times that planes P and Q intersect. Well, plane P's over here, plane Q's over here. They never intersect, so we can say 0. All right, let's move on, and in this last bit of the section, talk about the coordinate plane. A lot of this is going to be a review for you, okay? There are several key features of a coordinate plane. We have the origin, which can be called point O. It's often called point O for origin, and you oftentimes see an O kind of over there in the corner, okay? That's the letter O, not a 0. You can also denote it by ordered pair, 0, 0. Axes, we have 2 of them. We have the x-axis and we have the y-axis. As far as quadrants go, we label them by the 4 regions. They are the regions labeled 1, 2, 3, and 4, and we use Roman numerals for them. And then for the coordinate plane is the plane containing the x and y axis. So the x-axis and y-axis. All right, every point in a coordinate plane can be denoted by an ordered pair, like 0, 0 that we talked about above. And it consists of 2 numbers, the x-coordinate and the y-coordinate. To determine the coordinates for a point, you start at the origin, count the number of units to the left or right. Positive direction is to the right, negative direction to the left. Then you count the number of units up or down. Positive direction is up, negative direction is down. Again, I believe this is mainly review for you. So let's do a few examples. We're going to write the ordered pair for each point shown here. So for P, we have the ordered pair -4, -1. -4 on the x-axis, -1 on the y-axis. So -4, -1. For Q, we have the ordered pair 3, -1. For R, we have 3, 4. And for S, we have -2, 4. We can also go the other direction. Given an ordered pair, we can plot the coordinates. So for A, we have 5, so we go to the right 5, -2, go down 2, there's A. For B, we have 3, 3 positive 6, so over 3 up 6. There's B. For C, we have negative 6, 0. So back 6, and we stay there for C. For D, we've got negative 4, 3, which would be here. For E, we've got negative 3, which would go right here. And for F, we've got 0, 4. So we don't go left or right, but we do go up 4. And that gives us F. All right, one last example. If you've ever used an old road map, you probably noticed that there are numbers on one side of the map and letters on the other. This is to help us find where things are on the map. So for A, what part of Walt Disney World is in sector B4? Well, let's go to B4. Here's B, here's 4, and we find that the Magic Kingdom is the part of Disney World that is in that sector. In what sector is the city of Dr. Phillips? Well, Dr. Phillips is right here. So it's a little bit on the edge, but it does favor the E side and the 5 side. So it is in sector E5. E for our X coordinate, 5 for our Y coordinate. In what sectors is Lake Tibet? Well, Lake Tibet sits right here. So it's in D, and it's in D5 and D6. So we say D5 and D6. And then finally, what road goes from sector B3 to D2? Well, here's B3 right here, and here's D2 here. So it looks like Epcot Center Drive is that road. All right, so that's pretty much all we have for section 1 of Unit 1. As we move forward, we're going to be talking a little bit more about lines and parts of lines in section 2. Section 1, 2 is going to be on segment relationships.